So now, so is machine learning a different subject than data science? Because you get to see these topics separately at times in different universities and professional institutes. Uh, you know, I will say yes and no both. Look, I mean the point is that there is no black and white boundary between these things. Data science is a superset. It includes everything. Okay, whatever is under the umbrella. Now, each of these subjects are very specialized subjects. So you can actually take a deep dive into machine learning and buy, three books, each of 800 pages, and start reading them. So, you can definitely consider them as a different domain. A lot of work has been done. But finally, it is not about what you call them. You can call them artificial intelligence, you can call them machine learning. So basically, it's all about analyzing data. That's how I see. That's how I have grown up in the corporate world in the last 19 years, right? Saying that stages of data analysis. So you start with the basic things, you go to the next stage, then you go to the next stage, and once you are actually onto the latest technologies, to be honest, a lot of these technologies are actually, uh, evolving as well. So machine learning is evolving. A lot of new techniques have come up in fuzzy logic. Again, so what is fuzzy logic? So fuzzy logic is part of artificial intelligence. It's the highest end of the spectrum, if I can say so. And to just give you again a conceptual understanding, not the technicalities, in this session. Uh, Suppose you are a barber, okay? That means you are in a salon, right? And you are wearing a T-shirt which says that I shave people who do not shave themselves, and that's right. Okay? There's no ambiguity with this sentence. But then think about it. What happens when that person shaves himself in the morning and comes to the salon? So the statement that I just made, that he's wearing a T-shirt which says that I shave them who do not shave themselves, and in the morning he is shaving himself. So is this statement right, wrong? And that's where the fuzziness comes in. Right? At times it's very confusing, and that's called as fuzzy logic, and that's part of the artificial intelligence. That's the highest, I'll say, the complicated, uh, you know, uh, really complex algorithms that people are working with, right? And that's also included in highest form of robotics and other things, right? So one is basically that starting with data. So how do you store data, access data, mine data, the different ways. It's again a misperception that when I talk about analytics, data science, it has to be big data. No, you can still work with hundreds of GBs of data, which is in a structured form, stored in a conventional database like SQL, Oracle. You can very well pretty much do it. You can also access data from legacy systems like that of mainframes of the world, like S390, S400. There's no problem. But depending on the usage, big data is also playing a big role these days, because big data will store data in a distributed format, will take less of space, less of cost, access is fast, and it's very easy to archive everything into a small space. So big data is also playing a big role. There are applications in social media which has to use big data platform only because of the four V's that I spoke just now. So everything will exist together, right? It is not mutually exclusive. Everything will exist together. But then these are the data storage types. And then once you start analyzing it, you start with very basics of statistics, maybe descriptive. You move on to something called as inferential statistics, which is the frequentist method that most of us are taught. If we are taught anything about statistics, it is the frequentist method, which is the hypothesis test. It's a null hypothesis, alternate hypothesis, HO and HA. There's a p-value probability, and then from there we start inferring. You move on to the next level of machine learning. There are two kinds. One is supervised, another is unsupervised. Supervised means it's guided, right? You know the outcome. of the past transactions. You know something failed, something passed. In terms of cancer patients, you will know that uh, how many patients in the last 5 years in Tata Cancer Institute in Mumbai survived and how many of them didn't survive. And you have got each and every parameter of all these patients. So now, because you know the outcome, it is called a supervised machine learning. So you take the data, try to model it, and then when a new patient comes in, you try to forecast the probability of his or her survival. You know, that's a supervised learning. But then when you actually go and start watching videos on Amazon Prime or Netflix, it is called as unsupervised learning because you know it's random and there's nothing called as good and bad. So you try to cluster them and try to form a path onto which the customer seems to be following, right? And then you want to get into advanced algorithms, like I said, fuzzy logic, artificial intelligence, robotics. Those are advanced methods. So these are the spectrum of the things. One more thing that I should call out here is technology and the principles of the subject. So please understand that, again, as I said, the fundamentals of all these things, machine learning, artificial intelligence, statistics, mathematical computing, techniques like Markov chain, Monte Carlo simulation, these theories, principles, concepts are not new. These are there for the last 35, 50, 80 years, depending on which is the topic that we are referring. But then what has happened is that we have got now softwares like SAS, R, Python, and a lot of other things, right? As I said, IBM Cognos, IBM Watson, right? So these are the softwares which are actually taking these algorithms, coding these algorithms inside their brains, and helping us to just execute them to get the inferences. That means that even if I do not understand every bit of the step of the mathematical algorithm of a machine learning technique, but even if I understand saying that the basic working principle of it, I need not code it and all that. Someone is coding it for me, and I'm using this, to process my data, get some outcome, and start drawing the inferences. So let me take an analogy to make you understand it. If you are a pure physicist, then you may actually follow the path of Einstein, Archimedes, or Dr. Ohms and come up with Archimedes principle, Ohm's law, or Einstein's theories, right? If you're a pure science, graduate, postgraduate, doctorate, postdoctorate, that's what you tend to do, right? But when you are an engineer, studying a marine engineering course or a mechanical engineering course, you need not get into the details of it. An engineering course will actually have 40 subjects in 4 years, 10 subjects each year. You do not get even time to get into the depth of it, but you definitely understand the applications of technology, right? You will actually use the Archimedes principle to design a submarine, and you need not get into the pure science R&D labs and all that, right? So that's the difference between an analyst and a mathematician and a statistician. A mathematician may come up with Monte Carlo simulation, Laplace transformation, Fourier series. A statistician may come up with regression, with a lot of other things. But an analyst need not know, go to the depth of these things and come up with new, techniques. But an analyst needs to understand that given a problem statement from the business, do I apply something called ANOVA or a chi-square or a logistic regression or a k-means clustering? So that I need to know. So for that I need to understand that under what circumstances these methods and tools should be implemented, what are my assumptions, what are my constraints, and when I run these algorithms, when I get the outcome, how do I infer? And that inference should be relevant to the business. So I can't be a mathematician or a statistician and say, oh, I have run a two sample t test. By the way, the f value is so much. and the p-value is something which is below 0.05, and hence I reject my null hypothesis and I accept alternate hypothesis. If you call out this to a CXO, he's going to fire. So you can't say all that. So you need to understand these things, operate these things, but to a CXO, you need to call out what is the business recommendation that is going to either improve his top line or optimize his bottom line, because that's what business people will understand. So these are the things. Again, to summarize, I will say that start with data, means and ways of storing, accessing data. Big data is more from a data perspective. You then start analyzing data. You initially start more from statistical methods, go on to some of these high-end things in statistics, like forecasting, machine learning. But as and when you actually go, move up the spectrum, you actually tend to get into computing methods as well, right? As I said, high-speed computing and other things. So that's the entire spectrum. Uh, and then there's one part which is basically coming up with algorithms, theories, principles, and the other is that there are different softwares and tools which are also there to implement these things. So, which tools are good for what? So let me give a brief thing on that. So SAS is a very popular tool. I'll say that almost 50% or 40% of the market is captured by SaaS at this point in time. But what is more interesting is that what was the scene 5 years back or 6 years back? 6 years back, SaaS used to have more than 60-70% of the market. So that's more important. So SaaS is very costly, but then SaaS is very popular because SaaS has got a lot of compliances. It's a time-tested, proven platform for ages together. For clinical trials for pharmaceutical companies, SaaS got a lot of FDA approvals for the algorithms that they run. So for any pharmaceutical company coming up with a new molecular structure for an antibiotic in US, which needs FDA approval, SAS was the default choice for running the statistics for clinical trials, whether it's animal testing or human testing, right? Even for BFSI domain, as I said, banking, financial, mortgage, because of the FDA approval, SAS was the default choice. But again, let me repeat, at this point in time, SAS is standing at 40% of the market. R has come up very fast. It's an open source. SAS is proprietary tool, like Microsoft's tool, but R is just like Java. It's an open source tool. It has come up very fast in the last 5-6 years of time. It has it came first in the market around 2008 or 9, but then it has traveled a long distance, and it has matured a lot. Now there are other tools as well, like visual tools. Visual tools will be like Tableau. You've got SAS VA, that is called as SAS Visual Analysis, SAS VA, and then you've got Sisense, you've got ClickView. So these are the products in the market which are basically giving you quick analysis and great visual graphics, right? Of bubble charts, line charts, box plots, percentiles, Pareto's, pies, and all that. Okay? And then you also have other tools like IBM Watson, uh, and IBM Cognos. These IBM Cognos is more of a reporting tool and with built-in intelligence. Oracle has come up with some of these things, and IBM Watson has come up with this thing which is called as artificial intelligence. So let me tell you a bit about that because that's important. IBM Watson actually takes advantage of open data. That means if you actually upload a picture of a cat, it will not say that it's a picture of a dog, okay, or a lion. So it's going to say by analyzing the picture that it's actually a cat. But then, how does it do that? So first is basically the contour saying that there's a cat, there's not a lion or a tiger, and then maybe it can actually analyze as a second layer even the dimensions of the whiskers. So it will actually then go about analyzing the dimensions of the whiskers, saying that look, this is actually not a a tiger but a cat, right? Now It's built on machine learning. How? Thousands and hundreds of thousands of users will keep on uploading image on IBM Watson, and then try to tag it, predict it. So it is learning from the open data system. More and people will use IBM Watson. Actually, IBM Watson's intelligence will grow, okay, and it will be more fast, right? So that's how the machine learning is used within IBM Watson as a tool, to make it more intelligent. But that is like based on open data. Similarly, Google, whenever we go nowadays, we say that okay, I need to go from Hoscos to Noida, or I need to go from Arkepuram to Gurgaon. Let me figure out the best route, and I'll log into Google Map. I'll say start. Now Google will tell me that which is red, which is blue, which is green, depending on the density of the traffic. How does it tell me that? More and more people log in to Google. It actually helps the the public data to let me know, saying that okay, what's happening. Okay, and Google is using what? So Google for doing this is using big data platform, because please understand, millions of people in India are using Google Maps. Every second they're uploading data. That means you are sending some signal. It has to get that signal, store that signal, process that signal, and send back to you saying that it's a red or a blue, depending on the of the traffic density, right? So it's storing that data live, unstructured data in a big data platform. It is actually using high-end algorithms, statistical as well as mathematical, to process it, and then it sends you back in a very easy to understand and see an app for you to navigate the roads of Delhi, right, or any metro for that matter. So that's what it is. So that's the entire landscape of the tools, techniques, methods, principles of data science. Okay. I hope that helps you a bit in understanding the boundaries. I know, I mean, 15-20 minutes may not be enough for such a vast thing. There are other deep dives which are there available. You can go and see on the net. The next section that we will cover is more onto the career, and we'll talk in depth on that. Thank you.